A very pleasant good evening to everyone. I'm Gurtej from Board Infinity team and welcome you all to the new workshop, Introduction to the PostgreSQL. I guess everyone is now ready and very excited about this workshop. For more videos like this, please do like and subscribe to the Board Infinity channel. And if you are someone who want to start your career in data science, then check out our website www.boardinfinity.com, and within 24 hours our counselor team will get in touch with you. Without wasting time, I would love to welcome our coach Karmugilan sir, who is having more than a 4-year experience in specifically data science domain. So thank you so much sir for connecting with us today, and we are good to go now.
Yeah, thanks, Gutosh. Hi, all, everyone. Good evening. So, let's start for today. Today, in this workshop, we are going to discuss about PostgreSQL. So, we have seen in our other workshop, other discussions in the other part, what is SQL, and then how to go with that and why it is important. Of course, here we have to start with it. In order to go with that, let's have an idea of what we are going to discuss today, and then how we are going to connect the SQL along with the PostgreSQL, how it's connected, what are the differences. Let's start. So yeah, this is the agenda for today. In a way, like, we are going to see what is PostgreSQL. Then we are going to discuss about the difference between PostgreSQL and the other databases, as like MySQL or other thing, anything in general. Then we are going to discuss about when to use PostgreSQL. Okay, because there is a specific characteristics of every SQL. So we are going to pinpoint it in a specific manner when to use PostgreSQL and when not to use PostgreSQL. Then we are going to discuss about the data size limitations of it. But in order to start with the first one, what is PostgreSQL? How we go to get that is that in order to know that we have to go with what is SQL. So right before we get into the topic, the agenda for the next workshops, we are going to discuss about the tool, in a way, like how we are going to use PostgreSQL and what is the tool about it. So we are going to discuss about it in the next workshop. Then we are going to discuss about the data types and then the query comparison with the other SQLs. Simple as that. So this is what an entire agenda for PostgreSQL. Let's start for today. What is SQL? So the question comes in, why do we wanted to actually think about what is SQL when we are discussing about PostgreSQL is? So it's a overall topic in a generic manner. This topic seems to be fine, but an idea of why we wanted to know this is SQL and then where do the PostgreSQL comes in place, that as a whole data analytics cycle, as a life cycle, we wanted to know how important SQL is. If we get to know how important SQL is, then taking a choice of what SQL can be a right fit for you, then you can take it forward easy. So that is an idea. So in order to go with this, in order to get along, so we have to get with this, what is SQL. So as everyone, I strongly believe everyone have a basic idea of what is SQL. So SQL is basically a structured query language, which is a domain specific in general, and which is being used for querying the data, extraction of any data from any databases. Simple as that. So it's going to extract data for you from any of the database that you have been working, that you're about to work with, or that you're working on whatsoever. Okay, but the idea is this specific in a way, like the statement level. SQL is a domain specific language used in programming and designed for managing data held in a relational database management system. So this is the very common idea of every SQL, in a way, like it is going to extract data or manage data from a RDBMS, so a relational database management system, right? So this is what a basic idea or the purpose of SQL are for stream processing in a relational database management system. Think about it. Either we are going to extract data or we are going to manage the data within the RDBMS thing based on the SQL language. Now the question comes in, if SQL is a language, then why it is as a language, why it is so important. It can be a query language, but as a query language, why it's so important. So this is what an idea is, why it is important. As we all know, SQL is one of the most important language in data science. But as a important language, how can we quantify it? How important it is? This is where it makes the difference. In the earlier stages, maybe if I ask you in a general, which language is more important to get into data science? I'm sure that everyone would come with Python mostly, or basically R, or any programming languages which can do machine learning part. We always think about like machine learning is the hardcore data science. Machine learning, deep learning, Python, maybe predictions about weather, IPL prediction, or bank level prediction, fraud detection. Many things we keep talking about, but the reality is, in order to do all those predictions, in order to do all those, what is that, forecasting, or anything that we wanted to foresee beyond data, is that we need data to support it first thing. But where do the data is coming from? Even today, maybe as I told, maybe we have been discussed even in the previous workshops, in a way, like the differences between um, warehouse and an data lake. So the idea is that even today we can talk about big data thing. We are saying that like data engineering has been like getting maybe like more traction nowadays. Yeah, it do get traction, but the problem is SQL, beyond SQL, okay, the traction that has for data engineering is far low actually. Okay, in reality, as a business level, if you think about it, without SQL, you cannot do any data extraction or any data management in general. That is how important it is. Okay, so to be give it in a statement, SQL is the most mainstream language that is used to access databases. You know what? Even today, maybe like we can think about like say SQL. When I was a kid, I just heard what a SQL is. Should I want to learn outdated language? Maybe we feel that it's so ancient language, not maybe not outdated, maybe an ancient language. It's so old, 20 years old. Should I wanted to learn that? Why do I still wanted to rely on that? It is that even today, that's the most mainstream language to access database. Think about it. Okay, and you know what, going forward, don't think that it might lose traction. There is a high chances that the traction is going to keep increasing for at least for another decade for SQL. Okay, so that what is that, that's how important it is in general, to put it. So don't think about like I don't wanted to learn SQL because it's so old, and then like even for interview I will not give much importance to that. I will just give an importance towards Python, machine learning, Tableau. Yeah, everything is okay to have, but at the same time, SQL is a must skill. Okay, that's very much important. Look at it. Most popular language for data in 2021 is basically SQL. Think about the priority. It's not Python, it's not R, it's not any other programming language which can support data. It is SQL. It is because with Python you can do machine learning, but without data, how can work with Python? Okay, so we need database management, we need queries to be placed, we need data to be extracted. In order to do that, yeah, SQL. Then the next one, 45% of all data jobs listed, may what is that listed mentions SQL as a must skill. In general, you know what? This is an idea that this stat, the 45% of all data jobs, is actually for 2021. It's not even the very old data. It's just for 2021. Okay. Now what you can do in general manner is like just go to LinkedIn or any job portals. Just look for any data jobs. Okay. Out of at least 10 jobs, you will find 5 to 6 jobs. Either a data analyst, either a business analyst, either a data scientist. You look for it, SQL will be there as a skill. Okay, so don't ever underestimate SQL's importance in a data job. You know what, it's not going to take much time to learn SQL. Okay, I would strongly say that like in order to go with the select queries, DML and DDL queries, you can just learn it in 20 hours. But the priority, the importance we give is so less for SQL. That's the actual reality. And especially if you are a fresh job seeker, or if you're just wanted to switch domain into data science or something, concentrate more on SQL. Okay. Then, of course, in this workshop, we are going to give you an idea about what PostgreSQL is, how it is getting differentiated, and then whether you have to stick with PostgreSQL or MySQL. Choices coming follow, but ideally, as a whole, don't ever underestimate the importance of SQL. Very much important. Okay. And the question comes in, why this happened? Yeah, of course, the increased data collection ability. Okay, so we have the high strong data collection ability nowadays. Okay, earlier, think about it, it's not going to be maybe 10-15 years back. 128 GB of what is that, that was the hard disk for a general laptop 10 years back. Think about it. Now it's just like 128 GB, you get it in your mobile, so easy. So the collection, the data collection ability has been exponentially increased, either structured, unstructured, or semi-structured. Any data, the collection ability exponentially increased. This is where, think about it, out of like 100 companies, if I ask you tell 100 companies, we always come up like Google, Facebook, Microsoft, Amazon, that way. But think about it, if you think about the actual companies like that, it's going to be just like maximum 30-40 companies you can name that way. Those companies has a different requirement altogether. Okay, in a way, like they wanted an unstructured data, they want a semi-structured data, they want the structured data. Everyone works that way, those companies. But beyond that specific, maybe 20 to 30 companies out of 100, think about it, rest 70 companies works still on RDBMS. That is the reality. Okay, so the increased data collection ability is not just for unstructured data, not images, not just videos. Okay, maybe if you think about like, yeah, YouTube, think about it as a huge data. But the idea is that they don't process the entire videos of every videos. They process all the data about the video, metadata of the entire YouTube's, either channels or videos, or number of views, number of minutes that's being watched, number of ads being displayed. Everything is about being stored in a metadata. Think about it, that metadata is going to be structured, and then it will be stored in some RDBMS in general. Simple as this. That is why RDMS still holds a strong place in any analysis form. Simple as that. Of course, understanding the pattern in an image seems to be fascinating, but the reality is, how many employers do work on that is the real question. Out of 100 question, less than a 20 companies, even 20 is a very high number, guys. Okay, less than 20 companies will go for that sort of an unstructured data analysis or something. Rest 80 companies at least of will are actually working still on RDBMS thing. Even those 20 companies works on RDBMS reports for specific teams or specific analysis, but almost other 80 companies still completely relies on RDBMS. That is where SQL comes into play. Simple. That's an idea. So these are the reasons why we have to learn SQL. We should not be giving less priority for SQL. And as I told that, I repeat, I insist again, if you are a fresh job seeker, or if you are a what is a person who wants to switch domain to data science or something, make sure that you give high priority and the first priority to SQL. And I repeat, SQL is not an optional skill. SQL is a must skill. So now, being said with what SQL and why it is so much important, let's get with the popularity of it. As I told that, the most popular language for data jobs in 2021. Look at this. So not Python, not machine learning, not R, not Spark, anything. It is SQL. Okay. So this is an idea, guys. So make sure that you give priority and then you just stick to it, you learn it. Simple as that. Now, the idea and the agenda for today. What is PostgreSQL to start with? So now we just had a short brief about what is SQL. Let's get into here. What is PostgreSQL? Maybe many of you could have been heard MySQL more than PostgreSQL. I strongly believe few of you could have not even heard about PostgreSQL. but ideally like few of you could have, but many of you could have heard about MySQL. So what does it make PostgreSQL so unpopular comparing with MySQL? Then if it has maybe its the complexity or the architecture, everything is so good, then why it's so been like less popular? Not actually less popular. That's an idea. PostgreSQL is basically community driven. And yeah, let's start with the basic idea here. What is PostgreSQL? PostgreSQL is basically an open source object relational database system. Maybe there is a word change here. Look at it. We have been discussing MySQL as always about RDBMS, Relational Database Management System, or general RDBMS we call it. But think about it here. When we talk about PostgreSQL, we say it open source, object relational, not just relational, it's object relational. So what is this first word? Maybe open source. I believe everyone understands it. Self-explanatory in a way like open source is basically accessible by everyone, which is not being handled by an organization or an entity for any enterprise products. In a way like it can be accessed free of cost for anyone, and the source code is available for everyone. Simple as that. That is what the open source mean. But what does object relational database mean? What is the difference comes in? Why do we have something called object relational? What does this actually mean? Have anyone any idea about it? What is a object relational database? In general, what do relational database supports? A regular MySQL supports. In general, MySQL goes with any, what is this one, a database that we create. It just sticks to a schema. The schema would be directly referred and then can be accessed by the database systems. Simple as that. That's why we call it as a relational DBMS. Object relational is that at the same time of creating or maintaining a database system, we can keep objects towards it. We can add objects towards a entire system. It's not just about the being the schema level detail. It is going to be an even object level relational database systems can be created. So what is that, and then how do we create it? Yeah, that's for the next topic. We're keeping it. Next, PostgreSQL. 15 plus years of active development phase. Think about it. Maybe many of us think like PostgreSQL is not that popular, maybe because that we don't know this one. What is this? Hmm, how do I say? PostgreSQL, because in a recent time it's not just about what is this? In a recent time, maybe a new programming language, new query language. Not actually, because PostgreSQL is a very old language with 15 years of active development. So the question comes in. So is that like older than SQL, MySQL? No, actually not. MySQL is even more older because MySQL was so mature in relational databases. But when it comes to what is this one? PostgreSQL, the introduction and the talk was actually happened after the general object-oriented programming. I believe everyone understands what a or the object-oriented programming in a way like Python or a Java or a C, C++, any object-oriented, OOPS-based languages. When that sort of things started evolving, this is where the new idea came into. Why not we have a SQL which supports a object, basically that sort of an idea, an object based RDBMS. Why not just a regular? Why it should be just a relational database? Why can't we have an object based and regular object oriented sort of relational database system? Then the PostgreSQL being like introduced by graduates as a project, then everyone started contributing towards it, then everyone what the made the development for the last 15 years, and it was so active, which is completely a community driven thing, where it wasn't being associated for any organization or any specific entity, so that it remains open source. Simple as that. Here then, yeah, proven architecture, the second point. Once we get to know about like 15 years of active development phase, what are the architectures being proven with the what is this one, PostgreSQL. So in this one, PostgreSQL, the architecture works more for security. Maybe we can think about like, is that MySQL is not secured enough? Yeah, it do say it is secured enough, but at the same time, the levels of security that being designed in the architecture is bit, what is that, advanced in PostgreSQL comparing with MySQL. A basic idea, simple as that. That is why PostgreSQL is not what is that. Highly used for replicating a work, but whenever it is used is about the security level idea. When you wanted to have high security or high secured functionalities, then of course that is where the PostgreSQL's architecture comes into play. So it has a very strong proven architecture for a higher what is it, security things, simple as that. Then the next one, strong reputation. Yeah, this is where, think about it, it's just interconnected. Strong reputation for reliability and data integrity. Of course, when we talk about data integrity refers the strong security, simple as that. So there is no data leaks happening, or it's not easy to crack down a database system that way. So the data integrity is stronger, and that has a more reputation for PostgreSQL. And reliability, yeah. So when we talk about reliability, it is that when it's how accessible it is, the it refers to the reliability here. So since it is a community driven or development, completely of community driven development, it was so easy for everyone to access in a way like the community. Whenever advancement or architectural changes comes into play, it is completely being documented and then being shared in the open community, and all the data, all the architectural design and the source code is available for every individual. Maybe like yeah, similar to MySQL, but at the same time, since MySQL was being introduced or being maintained by Oracle, and then they keep wanted to improvise it, simple as that. But here, since it is not about a specific organization, since it's completely of what is this one, mm, community based driven one, so it's not completely sticking to an organization which have some agenda in order to make it work better or to execute better. This makes it more reliable so that everyone can access all the documentation, and every access, maybe the what is the source code of it, makes it so reliable for everyone. So that is having one more reputation for PostgreSQL. Then PostgreSQL is not controlled by, yeah, exactly, as I told that it's not controlled by either a corporation or a private entity, unlike the other SQLs, simple as that. So thus command structure for PostgreSQL is different from MySQL. Almost I would say, maybe like yeah, in a way like PostgreSQL, MySQL, or Oracle DB, or basically Amazon Redshift, or anything, any SQL that you go, okay, the command line of writing a SQL, whatever the SQL that you're going to use, maybe a transact SQL or anything, the syntax level, it's not going to have higher differences at all. So the select statement remains the select statement, from statement remains the from statement, where, having. So this sort of almost all the SQL queries in a syntax level is not going to have much of a differences. Okay. So, but think about it then, if that is having a higher syntax level differences, we will not be discussing this sort of theoretical discussions here. Okay. As a workshop, we could have been gone through direct syntaxes. But the idea is that it's not about syntaxes which makes the differences in SQL in general. Okay, so that's an idea for the next discussion for the differences between PostgreSQL and other SQLs. So it's not going to have much of a difference between the syntaxes. Okay, so yeah, not much. I would say like almost 80% of the syntax available in one SQL will be always be available with everyone, almost by similar to MySQL. The remaining 20% of it may be like different functions availability is actually there in PostgreSQL. Yeah, let's go with the next one. Difference between PostgreSQL and other DBs. I believe now everyone got what is PostgreSQL. Now let's discuss the difference between PostgreSQL and other DBs. Yeah, what makes it more complex? It's not going to be, it's not complex, but ideally, like, let's discuss the advantages and disadvantages. I think that would be getting covered with us. So here, first thing, difference between PostgreSQL and other DBs. The advantages of having PostgreSQL is highly secure. Okay, as I told, as we just discussed, the architectural design of the PostgreSQL is actually having high compatibility towards the security ideas. So whenever a DB which is being concerned about the higher security, of course it is being always used with PostgreSQL comparing with other DBs. That doesn't mean that other DBs are not having a, what is that, security, maybe having a security concerns, but comparing with other DBs, the architecture of PostgreSQL is highly been, what is that, coded or programmed in a way of for a high security where it cannot be breached or being hacked that way. And second one, of course, open source. So it makes it so much open for everyone, and the community based, community driven, what is the development, which makes it so much easier. Second advantage. Third one, high adaptability in window functions. Yeah, this is one of the most important, or the advantage for PostgreSQL. We can think about like, how come this can be advantage? What is that? High adaptability in Windows function. So isn't the Windows function available for every SQL? The reality is we think that Windows function or something that which is only for MySQL or that way. The idea is that MySQL is, sorry, the Windows functions are basically a concept. Okay, the functions that which will give a defined output every functions. But the reality is not all SQL have the window function adaptability. Okay, so that is basically the reality. We always think that every SQL have all the SQL maybe window function adaptability, but the reality is it is not. That is the biggest, what is the misconceptions in the real time. So if we wanted to know about it, look at it, the adaptability in Windows function, where the comparison, look at it here. I've just the image just compares this part, the image compares the window function part. Okay, but um, DB2, MariaDB, MySQL, Oracle DB, PostgreSQL, SQL Server, and SQLite. Okay, and look at it here. All this, now what are the functions being listed is basically of, what is that, window functions. Okay, these functions, and then the availability on the proper SQLs. Look at it again here. In MySQL, there is a, what is the window function which is not actually available, but the same function is available in PostgreSQL. Okay, the higher the adaptability for, what is this one now, window function, makes it one of the biggest advantages. As I told that Windows function may look like available for in all the window function is available in MySQL, but that's not exactly the reality. There are functions which is still not being supported by few of the SQL or the architecture. So this is one among an example for this. The nested window functions are something that which is still not being accessed by any of the architectures. The window nested window functions, maybe I'm not sure whether any of you could have tried it with your SQL experiences, if anyone would had an experience, but the real time property is that the nested window functions is still a massive question for many of the SQL architectures, because it has to be a bit complex in order to get the architectural design done. So many SQLs are still working on it, which is not been completed by most of the major players also. It's not even a minor players, even the major players like MySQL, PostgreSQL, SQL Server, Oracle DB. None of them have been achieved the nested window function so far now. Okay, so this is how the window functionality makes an important mm, distinction that PostgreSQL can achieve this. Simple as that. So yeah, then the next one, SQL compliance. Yeah, exactly. So the next important feature or the advantage of PostgreSQL, we know there are maybe in general 179 features of full core SQL, which is basically given by 2011, I think. The committee of produced that there are 179 features in order to claim any sequel to be a full core sequel. The functionalities that can be done in a sequel is 179. Okay, so out of that 179 functionalities, maybe it can be of defining schema or creating schema, updating the schema, or the manipulating or editing or anything, any actions. Okay, 179 features has been listed. Okay, out of that 179 features, PostgreSQL has been adapted with 160 of it, which is the very much remarkable number. Okay, so for now, and this stat was reported a year back. I'm not sure what is the exact number of today, but at least this stat was reported in a year back. 160 features of total 179 features being listed has been, what is it, been what is that, enabled in the PostgreSQL architecture. This makes PostgreSQL as one of the most important, what is that, top player. Maybe we can say that maybe Oracle or MySQL or a T-SQL. This has that compliance. So being said with this feature level property, PostgreSQL has one of the being the top three or top four SQL architectures which supports this many number of features. Simple as this. And you got a question. So the architecture, the command line we input makes it complex. Yeah, and Oracle DB is also good option, right? Yeah, Oracle DB is also a good option. At the same time, it depends on your need, because Oracle DB, how your data is going to be, and then what's enterprise thing that you wanted to go with. Either you wanted to go with enterprise or an open source, so you make the distinctions that way. NoSQL also good for compare all other DBs. NoSQL, no, NoSQL is different. RDBMS is different. Okay, so NoSQL is basically NoSQL. So there is a difference between a regular SQL and a NoSQL. So which is not actually this one. So PostgreSQL is basically a SQL. It doesn't fall under NoSQL. And is it user friendly? I think you're talking about NoSQL. If you're asking about NoSQL, maybe MongoDB is very much, MongoDB and Cassandra are very much user friendly for NoSQL DBs. Cool then. So going back to the topic, the advantages, yeah, community driven. As I told that, since what is this one? PostgreSQL is basically out by basically invented by graduates, so which is being what is that, improvised and contributed by the open community. It was never been what is that, under an organization or an entity to have any agendas to go with. It's basically to fulfill the full course SQL compliances. Simple as that. That's the only idea and agenda, since it's purely community driven, so it doesn't have any enterprise solutions. Simple as that. Then said this, yeah, the adaptability of window function, we have seen this advantages. Yeah, this is what the next one. So we have seen the advantages of PostgreSQL comparing with the other DBs. Now we are going to discuss the disadvantages of it. So the question comes in, So advantages seems to be fair, and then it was like being driven with community, being having a higher adaptability in window functions, and everything seems to be okay. What is the disadvantages? How it's going to affect the entire what is the PostgreSQL's performance? Yeah, first and foremost important disadvantage is memory performance. So the question comes in: what is the memory performance? How do it's being relevant here? Isn't this a query language? How come the memory differences would be coming into play? So think about it. Every query language has its own characteristics, as similar to PostgreSQL or MySQL. Anything has its own characteristics. When it comes to a memory performance, okay, what first thing in order to discuss is we wanted to know what the memory performance is. Yeah, the first thing is that the memory performance is about when we write a query. In general, how memory performance works, let me explain that. When we write a query in any SQL, we are trying to extract a data, or we try to change the schema, or we try to update a table, or insert a value or delete a value, some operation, some query we are writing. What happens is that for every query that we write, it hits the actual database that we are looking for, and then it just executes the operation. Here, when it comes to PostgreSQL, whenever you write a query, okay, basically for any new connection in general, to be precise, to put it in that way, any client connection, it forks a new process. In a way, like you execute one, that's done, then you execute the second one, it's not going to work in the same environment, it is going to create a fork, a new process. From the existing one, it is going to create a new fork. So fork, what is this fork represents here is that once you fork, you take the same work that it done already, and then you make a changes based on the copy that you made from the previous work. So your previous work will remain, what is that, unchanged. It will be like remaining the same raw thing, whatever it was there by the time you fork it. Then once you fork it, you put it in the second environment, it's not in the same environment. So before forking, it was just in one environment. Once you fork it, it becomes two environment now. In both the environment, it can be accessed. So it seems to be a positive thing. Yeah, let it be in two different environment. I can make the, what is the processing speed faster if that's the case. But the idea here is that, like, since it forks for every new process, that consumes memory. And you know what, then the question comes in, is that like have any limitations, or maybe guidelines to go for a new fork? Yeah, every operation which is demanded more than of 10 MB of size, it is going to fork a new process, simple as that. If it is a new process, of course, again it's going to consume a more memory, simple as that. So every fork that happens for every new client connection, the memory keeps extending. Once the memories keep extending, of course, the it just takes down the processing speed also. Once the memory is being consumed heavy, the processing speed goes down. That's an idea. That's one of an important disadvantage of PostgreSQL. Second one, for even a simple read heavy operations, okay, look at it. PostgreSQL is typically less performant than RDBMS, like MySQL. So even for a simple PostgreSQL, in a way, like read heavy operations, when we talk about read heavy operations, it is just about select statements. Whenever we have simple extracts, whenever we wanted to do a simple select extract files, even then we have this process idea. In a way, like every simple reads will be performed better or faster in RDBMS like MySQL comparing with PostgreSQL. This is the idea, guys. So what is this? Why do we want to talk about this advantage and disadvantage? Does that make any, what is that, no, additional senses to the choice of making a choice whether to go with PostgreSQL or MySQL? Yeah, it gives you an idea what to choose, and then how to choose, which would be a right thing to go, and then what can be the right DBMS setup to start with to go forward that way. So yeah, this is basically the disadvantages. Cool. The next two important topics: when to use PostgreSQL, when not to use PostgreSQL. Important idea and an important distinction to decide which is right to go with. Simple as that. So the first one, data integrity is important. So whenever we have this characteristics like in our project discussion or a real-time use case, when the data integrity is important, in a way like when we talk, I think everyone understands the data integrity idea. So integrity is something that when we wanted to have highly secured, it cannot be accessed or being shared with any other third person. That way, then the data integrity comes into play. How PostgreSQL makes it that we can use PostgreSQL when the data integrity is important is that PostgreSQL has to be fully ACID compliant. Okay, so it's been since like 15 20 years now that it has been fully ACID compliant. So what is this ACID compliant is that hmm, every committee in general, okay, have a, what is this one, a statement about whether this can be like, it's basically the ACID is basically the community or the committee which gives the guidelines about the data integrity. Okay, so this PostgreSQL is basically being fully ACID compliant. So whatever the nominations or the guidelines given by ACID, it was basically implemented in PostgreSQL architecture. This is why I repeat the initial discussion for PostgreSQL. Remember, PostgreSQL was working so much better in terms of security architecture comparing with many of the other characteristics. This is what the idea it was actually. So PostgreSQL has been fully ACID compliant, maybe almost like 15 years now, and the what is the term? Any guidelines that is being added by ACID is basically implemented to the architecture of PostgreSQL at the earliest, and it always remains consistent to make those changes. So making it a right choice of RDBMS whenever the data integrity is critical. So any project or any business which needs a data integrity as its most critical decisions to take in terms of choosing an RDBMS, of course PostgreSQL is one of the right choice to go with. First, an important reason when to use PostgreSQL. Second one, whenever the integration with other tools. Of course, we can think about like, oh, does PostgreSQL has better integration tools and options comparing with Microsoft SQL Server or basically MySQL, because it's being coming from a different two major corporations like Microsoft or Oracle. Is it really that way of easy to do the integrations? Yeah, PostgreSQL is basically compatible with a wide array of programming languages. Okay, so the programming languages and the platforms being given, which is available in the market, which is highly compatible with PostgreSQL, which means if you ever need to migrate your database to another operating system, think about it. If you ever wanted to migrate your database to another operating system completely, or integrate with a specific tool, it can be a specific tool or migrating to a different operating system, it is likely to be easier in PostgreSQL than any other DBMS that we have. Okay, think about it. There are even many free SQLs available, MySQL or any free SQLs available. But the idea is that it is that still it can be so much easier to do the integrations with this one DBMS thing. Simple as that. So with PostgreSQL, we can actually do faster and easier integrations comparing with other DBMS thing. It can be connected with any tools or a different OS. The migration or the integration is so easy, which makes as one more important reason when this sort of requirement comes in. Of course, PostgreSQL can be the right tool to go with. Think about it. You have a business, and the business is basically a startup in order to start with. So since it is a startup, you have no idea what would be the total number of data that you might collect, you end up collecting. Then you have no idea like what would be the veracity of data or varieties of data from a different departments. You have no idea. And then you might want to end up connecting to a different tools and technologies. Let's take, you want to connect with Tableau, you want to connect with Python, or many other things comes into play, maybe at different teams. This is where PostgreSQL comes into play. Then to choose what SQL can be a right choice of SQL can be PostgreSQL, because the integration and then the connection between the tools and the other languages are so easy in PostgreSQL comparing with any other SQL. Simple as that. Then the third important place when to use PostgreSQL is complex operations. Of course, I repeat, the architectural design of PostgreSQL itself is a bit complex, but at the same time, that makes it so much easy to perform complex operations. Since the architectural design was done that way, in a way like it can handle complex scenarios, it can handle complex executions. This is where PostgreSQL comes into play. Of course, it has memory problem. Remember the disadvantage that you have seen? It has a memory performance issue. But at the same time, the complex operations can be executed better in PostgreSQL, even though it has a memory problem, memory performance problem. So this is an idea. So if you wanted to think about the memory of maybe the complex operations, so the query, let's take PostgreSQL, suppose query plans that can leverage multiple CPUs. Okay, in order to answer queries with greater speed. Think about it. Maybe like the query that we are planning can have or can leverage multiple CPUs. Okay, maybe if execute a simple execution that needs multiple CPUs to come up with a conclusion, to answer such queries with a greater speed, of course, PostgreSQL can work better comparing with other DBMS. Why? Because the architectural design. The architectural design has such a complex, what is that, methodology to solve even the complex problem. Since the architecture is so intense, it can solve what is a complex problem at a higher speed comparing with any other, what is this one, DBMSs that way. So this coupled the, maybe I would say the, maybe a great choice of complex operations like data warehousing and online transaction processings. Basically, there's a differences, guys. Online transaction and online transaction processings. The processings are something that which needs a higher or complex rates. The number of transaction rates would be heavy, and then it cannot, what is this one, handle a complex execution at the same time. This is where PostgreSQL comes into play. So the data, what is that, schema or data processing, the transaction processing is not going to affect the complex architecture, the intense architecture, which can also handle a complex executions operations at the same time. So this is where we can use PostgreSQL. Simple as this. Then the next one, when not to use. So now we have seen the three places. The data integrity, whenever it is important, we can use PostgreSQL. Whenever the integration with other tools is needed and then which cannot be anticipated, we can use PostgreSQL. Whenever the complex operation comes in, we can use the PostgreSQL. So sorry, PostgreSQL. This is where the three places we can use PostgreSQL, which is recommended to use PostgreSQL. These are the three places which is not recommended to use PostgreSQL. Simple as this. First thing to start with, whenever speed is imperative. So in a way like your business demands higher performance. Okay, higher performance. Think about it. We just discussed the one of our biggest disadvantage of PostgreSQL, the memory performance, which is itself the architecture works that way. Okay, but when it comes to speed, in a terms of you wanted to have a results or query being performed or processed as fast as possible. Think about it. Let's take you have a n number of queries to be executed. We just discussed one of other disadvantage in a way like whenever we request for a new client connection, the new client connection is being forked by the architecture in order to get the what is that new output. So this process is something that which consumes more memory, which slows down the process, and then it just goes on and then to get the value. But when it comes to what is the disadvantages, that acts as a very high role, and then that says that it's going to affect the speed of the performance. So whenever if the speed is so much imperative towards the business, it's not recommended to use. To be put in a different frame, I would say, maybe to rephrase it, at the expenses of speed, PostgreSQL was designed with extensively and I would say, yeah, it was so extensible and compactability in mind. Okay, so PostgreSQL design, the architectural works in a way like it is more mostly to design about the extensibility to adapt with a multiple what is it, tools and languages, or to have a better compactability in mind, where at the cost or the expense of speed. So they know that when we go with this sort of an architecture, which works better for connecting other tools or the languages or the other extensibility possibility, we might end up losing the performance. They are okay to do it. That is how the architectural itself is basically built. That is why we call it at the expense of speed. Postgres was designed with extensibility and compactability. Simple as this. So this is what makes PostgreSQL the places when the speed is so much important when we wanted to work for the business demands it, we cannot use PostgreSQL, and it's not cannot, but ideally not recommended to use. Simple as that. So this is basically an idea of PostgreSQL. Second place when not to use PostgreSQL is that simple setups. Yeah, the second part. So what is this simple setup? This it just looks like a contradicting idea, right? So simple setups. How come when we have a DBMS setup, basically an object RDBMS, not even just an RDBMS, an object based RDBMS, uh, really getting so complex to have simple setups? Why it's not recommended to have a simple setup based places? Think about the ideology. You know what, in general of general oops concept, Python programming is the most recent and then the highly what is it speculated programming language. But you know what, that's the slowest of all the languages. Maybe like I would say like at least 200 percentage slower than C and C++. That much of slower language of Python is because of its extensible adaptation on oops concept, the object oriented idea. Okay, here when we introduce the object thing, object orientations within the SQL, the query language, the idea is that the architecture itself becomes heavy. First thing, so that when it becomes heavy, it can handle complex queries at the what is the cost of speed. But the problem is, in order to do that, we need the same architecture being replicated, right? The problem here is that architecture itself is complex. So if you wanted to get the easy setup. Maybe when you wanted to have your DBMS in the faster and the very much faster and compactable setup, then we need that simple setup to be done. But Postgres cannot afford the simple setup because of its complex architectural design. Since it has to undergo what is the initial, or the setup has to be bit complex, the places which we cannot use is basically like when we just need a simple setup to go for it, rather than we don't have much time to work on the configuring the setup. Yeah, of course, that is a place where we cannot use PostgreSQL. Of course we can use, but it's not highly recommended when you wanted to have a simple setup. Whenever you feel that no, I wanted to reconfigure MySQL architecture whenever I wanted, no, SQL or the PostgreSQL is not a right SQL to go for that specific idea. Simple as this. And then this one, third one, maybe like yeah, to just give you it in a statement level to rephrase what I've told, because of its large feature set. Okay, because of its large feature set, it can be an architectural design because it can handle complex features, complex queries of its large feature set, and strong adherence towards the standard SQL. Remember, even like out of 179 SQL features, they have been adopted with 160. So they have been strongly, what is that, adhered towards those standard of SQL. Postgres can be overkill for simple database setups, which is really complex, which is going to take time to get the installation or the SQL setup to be done. It's going to take time. But just because of adhering towards the standard SQL and then having a large feature set, it has to work that way. So for read or maybe like a general read heavy operations where speed is required, MySQL is typically more practical choice, I would say, comparing with PostgreSQL. So PostgreSQL is not that much of practical choice when we wanted to go for read heavy operations, because we need speed at the same time, we need a faster setup. So we cannot use a simple setup places and then this wherever the speed is required. Then the third place where we cannot use PostgreSQL is complex replications. Let's take in a way like you already have your network setup, architecture setup, and then you have been working on your some DB work. Then when the requirement comes and you wanted to replicate your existing DBs, okay, if you wanted to replicate the existing DBs, the idea is that you have to come up and then you have to replicate the existing one to optimize it further. Simple as that. But the problem here is you cannot, what is that, replicate it with a higher possibilities. So whenever you wanted to replicate an existing architectural design of PostgreSQL, the problem is it's going to be complex. So whenever you wanted to do it, it's not going to work the easiest way as possible. It's going to be the difficult processing time, speed, and the design. So to put it, maybe to rephrase it, so even maybe we can talk about this. Although the PostgreSQL does provide us a strong support for replication. Of course, as I told that in the community driven or the community, an active community, which was giving the documentation for every single access or the topic we wanted to do. The problem is, even though we have a strong support for the replication, it is still relatively new feature and some configurations. Think about it, as I told, it's basically a new feature in PostgreSQL comparing with other DBMS, where this sort of replication work are so matured in MySQL. This is where it makes the difference between MySQL and PostgreSQL. If you want to do a replication, it's going to be complex in PostgreSQL, but it is so easy in MySQL, because if in MySQL it's so matured field, it's not even lightly matured, it's a so strongly matured place of MySQL is replication. Okay, so it's basically an important feature for MySQL and it's so mature with that. And many users generally see MySQL's replication to be easier to implement. But think about it here, the replication itself is difficult, and then we have to implement it further, which really puts us a question whether we wanted to go for it. Simple as that. So this is places where actually we can not go with MySQL. No, sorry, in general of PostgreSQL, where the MySQL has a upper hand comparing in terms of the complex replication, or in a simple setup that plays a real bigger roles. Simple as that. So this is what the places where we cannot use PostgreSQL, guys. Got it? I hope everyone got this. Is it clear, guys? Everyone better? Just a theoretical discussion of all these Postgres ideas. Simple as that. Cool. Now, data size limitations. The next and the final idea of PostgreSQL to be discussed. Why we need, and then what are the characteristics of it. Data size limitations. So here, in general, maybe in with what is this? When concurrent execution needed, if it's effective. Okay, I just got a question. When concurrent execution needed, it is effective. Yeah, when a concurrent execution is needed, it is going to be okay. So it's not that maybe concurrent execution needed, it is effective. Yeah, in general we can call it as a effective because it can perform it better a complex execution comparing with other executions. So yeah, it is cool then. So yeah, this one, data size limitations. Now, so what is this data size limitations is that for every architectural design we have some limitations on top of the data of the size that can handle actually. Okay, so the first thing, limit, and the second one is value. What is the limit and what can be done when it comes to PostgreSQL DB? What we have is that the database size can be anything. There is no limit for a specific database. But when it comes to a table, one table, the data size of the any one table in a database should be less than 32 TB. Guys, this is not GB, it is TB, 32 TB. Okay, that is the maximum size available per table in PostgreSQL database. So when it comes to row size, it can have 1.6 TB of row size. Maximum field size it can be having of 1 GB of field size. In a way, like the question comes in, what is this row size, what is the field size? Is that the maximum number of rows as a row index property? That way what we can have is 1.6 TB. Field size is that it's number of fields that we have, the size of the number of fields should be less than a GB. This is what the maximum field or the limit that we have for general table and a row and a field size. Maximum rows per table is basically unlimited, so it can have any number of rows in a table. Okay, but the row size can be 1.6 TB, should be less than 1.6 TB. But number of rows can be unlimited, it can be of anything. So it depends on the field or the row property. We will be having the specific number of rows or columns being listed, so it can have unlimited, it can be unlimited. Then maximum columns per table. Okay, in one table it can have, it cannot have more than on what is this one, 1600. In general it's 250 as a or the maximum field, and till 1600 it can be extended. Why maximum it starts with 250 and 1600 is that it depends on the column data types. So the data types is basically a crucial part in PostgreSQL. Why do we wanted to keep database as a crucial part is that that's why I just put it as an entire session for the next workshop, because data types are something that which is more advanced, at the same time bit complex in PostgreSQL comparing with other SQLs. Okay, so it depends on the data type, the column type that we have been using in PostgreSQL, we can decide the actual number of columns. So the actual number of columns are not fixed, so as a fixed number of value, but it's around 250 to 1600, where in case like we have 160, sorry, 250 columns, but the data types are different, and then which holds a higher memory, then it's basically can be limited with 250. So the maximum number of columns per table can be 250 to 1600. Yeah, the indexes per table can be unlimited, which is basically the number of rows which is being given as an index. So the index of a table within PostgreSQL is basically unlimited. Simple as that. So this is what the data size limitations, guys, for PostgreSQL. Okay. So there are other characteristics or something, but ideally as an overall picture, these all are the or the idea of PostgreSQL, guys. I believe everyone had an idea about what a PostgreSQL is, and then when to use it, when not to use it, advantages, disadvantages, data sizes, everything. So yeah, this is an idea. Now let's have a quick recap of what we have discussed for. So we started with what is PostgreSQL. Then we have discussed with the differences between PostgreSQL and other DBs. It is mostly because of the architectural design and the characteristics of the execution. Simple as this. And when to use PostgreSQL, when not to use PostgreSQL, the advantages, disadvantages, and then the data size limitations, which we have seen for PostgreSQL. So yes, guys, this is an idea of to just to give you an introduction towards PostgreSQL. So as I told that the syntax between what is this one, PostgreSQL and other topics is not going to other SQL is not going to be having much differences. It's going to be remaining almost the same, around 80 to 90% of the piece of code. The syntax is going to remain the same, but the design and then the execution speed and then the other characteristics is what which makes PostgreSQL or any of the other DBs as a different property. Simple as that. So with this idea, maybe we can resume with the next workshop in a way like what are the exact syntaxes along with the data types for every PostgreSQL distinctions, in a way like what all are the data types available in Postgres, what all are the additional topics that we can discuss with or the compare with the other DBs, and then we can execute. But rest of the time it's not, it's going to be the same. What is this one, syntax or the piece of codes, it's not going to change much, which we will be seeing in the next workshops. This is it for today, guys. I hope everyone enjoyed the session, everyone have a understanding of what a PostgreSQL and then the basic differences between the others and PostgreSQL. Next week we'll discuss the piece of codes and then we'll just take it forward with the data types. So this is it for today, guys. See you guys over the next workshop. Thank you, everyone.
Thank you so much, sir, for the informative session. And dear participants, stay tuned with us. We'll be coming with a lot of workshop every Sundays, and this is the just a first session of the this workshop. So it will be continue in the upcoming Sundays. So stay tuned with us with the same timing, 4 to 6 p.m. in the evening. We'll be continuing this workshop. And once again, thank you so much, sir. And dear participants, if you like it, this kind of workshop, then please share with your friends as well. And thank you so much, everyone.